So to review what we talked about so far, when we have a complex number, we can write it in rectangular form, which is when we write it as a plus bi. A is the real part, b is the imaginary part. Or we could write it in polar form, which is when we write it like this. So we have the absolute value of the complex number, which is the r. Or the other way you could look at it is the distance from the center out to the point. And then we multiply that by cosine of the angle plus I times sine of the angle. And there's a shorthand way to write this. You could write it r cis theta. And the cis stands for cosine I sine theta. So what we've done so far is we went from rectangular form to polar form. And now in this video, we're going to go in the other direction where we're given polar form and we're going to write it in rectangular form. Now, something I want to point out, I made a mistake here, a typo. So go ahead and fix this. Part B, I missed my cis. So it should be negative 13 cis inverse tangent of 12 over 5. This is our angle, although it's written in a different way, but that's our angle. Okay, so for part A, this is clearly in polar form, and we're going to write this in rectangular form. When we write something in rectangular form, it's actually a lot easier. I'm just going to distribute my value of r, so I have 4 cosine 30 degrees plus 4i sine 30 degrees. Cosine of 30 degrees is the square root of 3 over 2. So I'm going to replace cosine of 30 with square root of 3 over 2 plus, and sine is a half. So I'm going to replace sine of 30 with a half. And then I'm going to simplify it, and we'll get our value of z in rectangular form. So when I take 4 times the square root of 3 over 2, that's going to give me 2 square roots of 3 plus, when I take 4 times a half, that gives me 2. And then I have my I. So this isn't written in rectangular form. This is my A. This is my B. So I have it written as A plus BI. Okay, now for this example in part B, it's given it to us in polar form, but it's written in shorthand, and it's given the angle in a little bit of a different format. Instead of directly giving us the angle as 30 degrees or 45 degrees, it's given us the angle so that we can make our triangle. Because negative 13 cis with that angle, it would be written like this. This is our angle. This represents theta. So I would have negative 13 cosine of that angle plus I sine of that angle. So if this is our angle and our tangent is 12 over 5, that would be opposite over adjacent. So I'm setting up my triangle. And then if I use Pythagorean theorem, I'll get that 13 is the hypotenuse. So now I can use that to find cosine theta and sine theta. Cosine theta, cosine is adjacent over hypotenuse. So I'm going to replace cosine of theta with adjacent over hypotenuse, which is 5 over 13. And sine is opposite over hypotenuse. So I'm going to replace sine of theta with 12 over 13. And let me make sure I get my I in there. 13i. Okay, so when I clean this up a little bit, I get negative 13 times 5 over 13, which gives me a negative 5. And then negative 13i times 12 over 13, the 13's disappear and I'm left with negative 12i. So here is my A, here is my B. So I have A plus BI. My A is negative 5 and my B is negative 12, and now it's in rectangular form.